So welcome back. Also welcome back, Magda.
Thanks.
So the last time when we spoke, we also brushed over the topic of material flow analysis. Can we dive in a bit deeper into this method?
Sure. So material flow analysis is usually used to map resources for materials or buildings, but also for entire cities or regions. So for example, here we have a material flow analysis of an entire city. And with this Sankey diagram, you can actually see where resources come from, where they're going, and also if they are coming back into the cycle.
Like here.
Exactly. So whether they are recycled or reused. And usually mass is used as an indicator, but for the EGIR project, we use global warming as an indicator. So for example, here you see that this chart actually shows the embodied carbon which is produced during the production phase of this component.
Nice. So we have here thick parts, thin parts, different colors, and a line. So this means if it's above the line, it's positive. And then if it's below, is it negative? Is it zero? What is it below this line?
Yeah, so this these lines, so these streams are actually the material composition. So in this case, we have an insulation made of PET, and this PET is in this material 80% we have of it here, and it's recycled. So that means it's a secondary raw material, and it goes below this line. And up there we have polyester fiber, 20%. So this is a primary raw material, so a virgin material. And why this line goes below the zero line is because it actually does not emit any CO2 emissions, because the CO2 emissions were already emitted in the first cycle, in the first production cycle, and are not added in this calculation anymore.
Okay, and this is because it's a second, third, fourth, maybe even fifth material that goes into a product stream.
Exactly.
Okay, so here we have the input, here we have the output.
Yes.
And this is more an equation. Here we go back into the below zero line because it's recycling.
Yes, so why this material output flow is grayish is because it's hard to estimate future materials flows. It's always more an indication where these materials are going to. And we are taking here the current recycling system. So we don't know how this recycling system will be in 20 or 30 years. So that's why it's more an estimation. So it really much depends how you put materials together, but also how we will develop our new systems in the future.
Nice. So here right now we have an example with a material above the zero line. Are there also materials that can go below the zero?
Yes, sure. So we also analyzed other insulations. For example, we had an analysis of a bio-based material insulation. And here there were actually wood fibers used, which were also recycled. So we have this stream below the zero line. But we also have this column below the zero line, means that this product stores CO2 emissions, because it's a renewable material. And where we talked before about the PET insulation, we can say that it's similar behaves in terms of CO2 emissions to an XPS insulation. But what we can see is that the XPS insulation does not use any secondary raw material, only primary raw material. So that's why we don't have any streams below the line. And also future recyclability is not given. This material is usually incinerated, so it also stays above this line.
What I really like about this image is that you see, okay, there's a material that's almost totally beneath the zero line, then we have one that's kind of in the middle, and then one that's clearly above. And all of those materials are insulations. So yeah, for us facade engineers, at the beginning when we're thinking about an insulation, a U value, we have different materials that we can pick up, and then using this method we see, okay, those three maybe have similar U values, but what happens in terms of circularity? And here we can clearly see there are huge differences.
Yeah, for sure. In this project, we use this methodology, which is a material flow analysis combined with LCA.
Yeah.
But I would say that it's always project-based, what method you use, because the location of the building is different, but also the recycling systems in the location in the regions are different. So you always have to have an individual solution and also select your best methodology to evaluate circularity of your project.
Which is a great point to point out. What are the main takeaways of this method? What are your conclusions if you think about material flow analysis?
I would say that material flow analysis is a good way how you can map resource flows. It's also a good method to visualize quantitative indicators such as secondary raw material or primary raw material, but also global warming potential. It's still hard to estimate future material output flows, but it's possible with this method. We can say that you have to select your own method for each scenario, for each project. And also it's important to say that this method does not evaluate qualitative indicators such as the mountability or durability. So it's always a combination of several methodologies, but also you as a designer have to keep in mind other indicators. So that's why it's also important to develop KPIs for your individual project at the very first start of the project.
Thank you. Especially what I found interesting here is that there's not one single solution to assess circularity, that there are options that we can choose from. Material flow analysis is one, maybe successful option for a specific goal, but there's still more work that we need to do, what is of course exciting also for researchers to hear, to know, here's something that we need to dig into deeper to understand. But it makes me excited about what comes next.
Yeah, me too. And I'm looking forward how you guys are going to develop or apply this method on your project or your products.
Yes, thank you very much. Also, thank you for listening, and see you soon.